Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. Today we will learn about the data structure, arrays in the Python language. The definition of arrays in the Python language is similar to that in other programming languages. But arrays in the Python language are one-dimensional arrays. Usually, is used to store a continuous series of data. The single data stored in the array is called the element of the array, and the types of these elements can be integer, floating point, string, color value, boolean value. The Python language on FMZ is not very strict about types, and it can even store strings and numbers in an array at the same time. Since the bottom layer of the array is also a series structure, if the historical operator is used to refer to the array state on the previous bar, so instead of using the historical operator to refer to an element in the array, we need to use the functions ArrayGet and ArraySet. The index order of the elements in the array is that the index of the first element of the array is 0, and the index of the next element is incremented by 1. We illustrate it with a simple code. In the last lesson, we have learned how to initialize an array. Here we declare a variable a and initialize this array with array from. We use the var keyword to declare variable a here equals to array from. Here we write 0 in it. Then we write a condition if bar index equals to 0. We use the runtime log function to print the array a. Then we click a backtest. Wait for a moment. We can see that the array was printed out. There is only one element in this array, and the element is 0 here. Then we continue to write. Go back to the code page. Else if bar index equal to 2. Oh, sorry, it's equal to 1 here. We push a bar index in array A again, then we print it again. We use array push function here. Then use the runtime log function. Print it again. And we click backtest. We can see that in the log message column, the second time the array is printed, it becomes 0, 1 here, because the second time is when bar index equals to 1 and bar index A is pushed. Here the array becomes 0, 1. Let's go back to the code page. We continue to write, else if bar index equals to 2. Then we push the array, then we push it again. And print it again. Then we click backtest. We can see that in the log message column, the array becomes 0, 1, 2 here. What would happen if we use the historical operator to make a historical reference to A? As we said earlier, we can use a reget and a reset when referencing elements in an array rather than using the historical operator. If we use the historical operator, what we refer to is the state of the array on the k-line of the previous bar or previous bars rather than the elements in the array. For example, we print array A1, A2 besides A here. That is the state of array A when referencing one k-line forward, and the state of array A when referencing 2 k-lines forward. Then we click backtest. We can see that it printed the array A first on the current k-line bar, which has 3 elements, 0, 1, 2. The array A becomes 0, 1, and when referencing 1 k-line forward and when referencing 2 k-line bars forward, it becomes 0 here. That is, when bar index equals to 0, the array becomes 0, which is the same as then. What are the ways to declare arrays? There are many ways of declaring arrays on the TradingView, which are also compatible with FMZ. except that FMZ is not as strict about type requirements, and some declarations can be abbreviated on FMZ. Here we write array int a to declare an array. We use it to declare an array. This array is full of integer values. When initializing, we use the function arrayNew. ArrayNew has two parameters. The first is the array to be initialized. It has several elements. If we write 3 here, it represents the array returned by this function has 3 elements to fill. What is the specific filling value on each element? The second element is used to set the specific fill value. Here we fill it with bar index. We create an array A containing 3 elements, each of them with the bar index at that time. Then we use the runtime log function to print the values out. In order not to output the message repeatedly, we use the runtime error function to stop after printing for one time. Then we click backtest. We can see that the strategy starts running for the first time, but index is 0. And then we do an array creation of it containing 3 elements. In addition to such array creation, we can also create floating point arrays. We can write float brackets b. Use the arrayNew function to initialize it. Here we write 3 and close. That is, B is an array containing 3 elements. Each element is filled with the built-in variable close. Then we use the runtime log function to print. We can copy and change them. We click backtest. We can see that the third array, it contains 3 strings here. Array variables are initialized by using array new and array from functions. There are also many types-related functions similar to array new in the Pine language: array new int, array new bool, array new color, array new string, etc. We can find them in the API function of the FMZ Pine script documentation here. We can use Ctrl+F for global search, and we use the function array new for most. We can find them in the contents. Here. We use the function array new for most. When we declare an array, in addition to noting how it is declared, we can also specify its declaration mode. The var keyword also works with the array declaration mode. Arrays declared with the var keyword are initialized only on the first bar. Let's observe with an example. We use var to declare a variable a. Then we use the array from function to initialize it. Let it be initialized to an array containing only one element, 0. Then we declare a variable b without var keyword. Also, we use the array from function, initialize it to 0. Then we modify it if bar index equals to 1. We use the array push function to add a variable bar index to array A. Same as array B. Push it again. Then we write else if bar index equals to 2. And push them again. We can copy it and paste it. If it runs to an end, that is the last k-line of bar state, we use the bar state is last function. Else if bar state is last, We use the function bar state is last for judgment. When it was at the last k line, we print them out by using the runtime log function. Finally, we throw an error to let the strategy stop. Runtime error stop. We click backtest. And we can see that the final output of A has 3 elements, 0, 1, and 2. And B only has 1 element, 0. Let's go back to the code page. The result of each push operation of A is preserved and not reset, while B is reset to 0 each time, and none of its operations of these pushes are preserved. That is, the var keyword used on arrays is the same. We should use the function arrayGet and arraySet when we read and write elements in an array. The first parameter of arrayGet is the array to be processed, and the second parameter is the specified index. Here we write a simple example. We declare an array first. A equals to array from. We use the string 1, string 2, and the string 3. Here it has 3 elements, these 3 strings. If we want to obtain the middle string, then we shall use the function arrayGet. The first parameter we obtain the array A, and the second parameter we obtain the index array. We obtain the index. And we can use the runtime log function to print it out directly. We click backtest. You can see it printed out 2 repeatedly. It's always printing 2 in the log message column. If we want to modify the string 2, we can use the function arraySet to modify array A, specify to modify the element with index 1. which we change it to A here. We can use the runtime log function to print it out. Just copy and paste it. And we use the runtime error function to make it print only once. Click backtest. We can see that 2 was changed to A here. Let's go back to the code page. We can print out all the array. We write it here. Use the runtime log function. We click backtest again. We can see it was modified to A here. It becomes string 1, string A, and string 3 from string 1, string 2, and string 3. How to iterate through an array? We usually use a loop structure to traverse an array, which can be used with the for in, while statements we learned earlier. Here we declare a variable a and initialize it with an array which contains 6 elements. If we want to iterate through it, we can use the for loop. We write it here. For I equals to 0. That is, when the initial loop count is 0, let it stop the loop. When it is 6, then we modify a by function array set. Specify its index location as I here, and modify it to 1. Then we use the runtime log function to print it out. Finally, don't forget to use the runtime error function to make it stop. We click backtest. We can see that it changed into 1, 1, 1, 1, 1 from 1, 2, 3, 4, 5, 6. But we can find it has 7 elements here. 1, 2, 3, 4, 5, 6, 7. It has 7 elements. Why is there an extra element? Because when we are iterating, we specify the value artificially. It is actually running to 5. When it is modifying the 6th element, making it run on one more element that is overflowing by one position. When iterating through the array, we need to pay attention to whether the length of the traversed array is 0. If the array is an empty array, it is definitely wrong for us to forcibly modify it. We need to judge whether the array has reached the last digit. So when we traverse the array, we use a for loop to traverse it. First, to determine what the final count is at the end of it. For example, how can we determine it here? We should determine what the final count is at the end of it first, and use array size to determine if the length of this array is equal to 0. Here, we write array size. If it's equal to 0. We use a ternary expression to determine it. If it's equal to 0, we assign it with the value of NA. If it's not equal to 0, we use the length of array size A minus 1. That is 6 minus 1 equals to 5. So 5 is the index value of the last element. If the final count of the for loop is NA, then the for loop will not be executed and it just skips. We click backtest to see it. Oh, it reports an error here. Let's go back to the code page to check them. We can see we use it in the wrong form and change it to the correct one here. And we click backtest again. We can see here it has 6 elements without an error. 1, 2, 3, 4, 5, 6. In addition, we can use the for-in loop to iterate through the array. It's very simple. We just write for element in. Here we declare an array by function array new. here we write 5, 0.1. It means there's 5 elements. Each of them have the floating point of 0.1. And we use the for in loop here. We write for element in A, and we use runtime log function to print it. Finally, don't forget the runtime error function to make it stop. We click backtest. We can see that in the log message column, it prints out 0.1 for 5 times here. If we want to use the index of the for in loop, we can modify it on the former code directly. We can write for brackets and don't forget to write x in the runtime log function. Then we click backtest again. We can see that the index was printed out. The value corresponding to the first index is 0.1 and the second 0.1, the third 0.1, and so on. Every one of the 5 elements is 0.1 here. Besides the for loop, we can also use the while loop. Here we use the function array from. And write 6 elements in it. And write let the variable I equals to 0. Use the while loop. While I less than array size A, I less than while I less than array size A, we use the runtime log function. Here we must write I, that is let it increment manually here. The index I is a global variable and it cannot change automatically. So we must let the index I increment. That is, when I equals to 6, it would not be eligible. Then I equals to 5 is the last element. Finally, don't forget runtime log error function to make it stop. We click backtest. We can see that it's 1 when I equals to 0 here, and it's 2 when I equals to 1, till I equals to 5, it is 6. The last element printed out is 6 here. This is how to iterate through an array by using a for loop and while loop. So that's all for today's lesson. If you think our video tutorials are useful, don't forget to like, follow, and repost. Your support is our greatest motivation. And thank you all, and see you next time.